Gradient of these lines then to 2dp. Back at the catch up with the last bit of the notes in the proceeding. The gradient of this line is the tangent, isn't it? So it's the tan of 30. Tan of 30 is 1 over root 3. But we need it to 2dp, so we need the calculator. So we're in degrees mode, and tan of 30 then, which is 1 over root 3, which is root 3 over 3, same thing. 0.577, 0.582d, isn't it? This gradient is tan 60, which is actually root 3, which is 1.732. So let's try that. Tan of 60, root 3, 1.732, which is 1.73. And this gradient of this slope, tan of 150, which will be a negative slope. Let's just tap that in. Tan of 150 then. Minus 1 over root 3, or root 3 over 3, which is minus 0.58, isn't it? If we go to the decimal just to be sure, minus 0.58. Now back to this question then, back to the notes just before. Equation of the lines, gradient through 1, 2, 1 minus 2 and 3, 8. Okay, let's have a look at this then. The gradient would be the increase in y, so the increase in y is 8 minus 2, divided by the increase in x from 3 minus 1 is 2, so the gradient is 5, 10 over 2 is 5. Intersection of lines then? Okay, well it's just simultaneous equations here. So because their y is equal, you can just let one equal the other, can't you, and have an equation in x. So I'll do the work above here and find the intersection then. So here we can just let them equal one another. 2x plus 1 is equal to 3x minus 1. Move the 1 over there to be 2. Move the 2x over here to be minus 2x, and just gives x equals 2. And when x equals 2, y is equal to 2 2s are 4 plus 1 is 5. And 3 2s are 6 minus 1 is 5, so yeah, everything's fine. And the intersection point is, coordinate-wise, is 2, 5. For this one, a bit more complicated, isn't it? We could triple this, so we've got 1 and 2. So we could triple this and just add them. So why don't we do that? So 9 of these, triple this is minus 3x, triple this is 30. So that's 3. And then these 3x's will cancel when we add them. So add this to this equals the adding of this to this, isn't it? So 1 plus 3 then gives 11y. These x's cancel, that's why I'll be doing it, equals 33. So that tells us what y is. Y equals 33 over 11, which is 3. And now we know y is 3, we can find out what x is from 2. So move the x over there. The 3y can stay as is. And we'll move the 10 over to be with it, so it becomes minus 10, doesn't it? So we move the x over here, put it there. We move the 10 over there, it became a minus. So 3 3's are 9, minus 10 equals minus 1. So we've got the coordinate minus 1, 3 is the point of intersection. So let's just try that. X is minus 1, y is 3. 6 minus 3 is 3. And minus 1 here, and 3. 9 minus minus 1 is plus 1. 9 plus 1 is 10. So everything looks good for that intersection then. So we've done that section there on the notes. So let's get rid of that. Here. Okay, now we'll look at this last little bit here. Equation of the line through 6, 1 perpendicular to this. Well, here you can see that y equals minus 2x plus 3. So the gradient of the line perpendicular will be a half, won't it? Because this gradient is equal to minus 2. So a perpendicular gradient must be a half, mustn't it? Because the product is minus 1. So y, we know that y equals half x plus c, but that line of that gradient goes through the point 6, 1. So at 6, 1 then, put 1 in for y, 6 in for x, 6 over 2 is 3, plus c, and that tells us what c must be. 1 minus 3 is minus 2. So the equation is y equals a half x minus 2. Okay, good. Find the intersection and sketch. Okay, so we've got two lines here. We've got y equals minus 2x plus 3. Find the intersection and sketch then. So do a quick sketch of that then. So we've got these two straight lines. I'm just going to do a quick sketch. And I'm not going to be too pedantic because I've only got a digital pen. Half x minus 2, so intercept is minus 2, gradient is a half. So it's quite a shallow straight line, so I'm going to try my best to draw it with this digital pen. A little bit too steep that, but that'll have to do. This gradient is intercept 3 and gradient minus 2, so it's a steep negative gradient, which I need to draw perpendicular to the other gradient to get it looking right. That's a bit better. There we go. And there's that curve there, and that one is there, so we've labelled them. This is the x, this is the y, this is the origin.